Apollo 1. Apollo 1 was the first crewed mission of the Apollo program intended to test the spacecraft in low Earth orbit before attempting a moon landing. On January 27, 1967, during a routine pre-launch test at Cape Kennedy, astronauts Gus Grissom, Ed White, and Roger B. Chaffee were inside the command module when a fire broke out. The cabin was pressurized with pure oxygen at 16.7 pounds per square inch, significantly higher than atmospheric pressure, making it extremely flammable. The ignition source was later traced to faulty wiring beneath one of the crew seats. The fire spread in seconds, and the crew was unable to open the inward opening hatch against the pressure. All 3 astronauts died from asphyxiation and burns within about 17 seconds. This tragedy prompted a complete redesign of the Apollo command module, including safer materials, a quick opening hatch, and changes to electrical wiring and atmosphere composition. Soyuz 1. Soyuz 1 was a Soviet spaceflight launched on April 23, 1967, carrying cosmonaut Vladimir Komarov. The mission faced problems almost immediately after reaching orbit. One of the spacecraft's solar panels failed to deploy, severely reducing electrical power and leaving many onboard systems inoperable. This also caused the spacecraft to tumble, making manual control extremely difficult. Komarov attempted to re-enter the atmosphere on April 24 after completing 19 orbits, but a parachute malfunction during descent sealed the mission's fate. The main parachute failed to deploy properly, and when the backup chute was released, it became tangled with the first. Soyuz 1 slammed into the ground at high speed, killing Komarov instantly. Investigations revealed multiple design flaws and poor quality control in the spacecraft's construction, leading to significant redesigns before future Soyuz flights. X-15 Flight 36597. On November 15, 1967, the X-15 rocket plane, an experimental aircraft designed for high-speed, high-altitude research, suffered its only fatal accident in over 190 flights. U.S. Air Force pilot Michael J. Adams was flying the X-15 on a suborbital mission, reaching an altitude of nearly 266,000 feet. At the peak of the flight, the aircraft began to roll unexpectedly due to a control system malfunction. As it re-entered the atmosphere, the oscillations grew more violent, and Adams lost control. The X-15 entered a spin at hypersonic speed, something no pilot had ever recovered from, and experienced forces exceeding the aircraft's structural limits. It broke apart over California's Mojave Desert, killing Adams instantly. The crash led to changes in both training and onboard instrumentation to give pilots clearer situational awareness during extreme flight conditions. Space Shuttle training aircraft crash. On February 28, 1981, during preparations for the first Space Shuttle mission, STS-1, NASA astronaut Robert L. Crippen's training counterpart, astronaut John S. Jack McKay, was participating in shuttle approach and landing training using a T-38 Talon jet. While on approach to Ellington Field in Houston, another T-38 carrying astronauts Carl Hennies and Robert Overmyer crashed due to poor weather and low visibility. Both astronauts were killed instantly. While not an in-space accident, this tragedy underscored the dangers astronauts face during flight training. NASA revised flight safety protocols, especially for poor weather operations, to reduce non-launch-related fatalities within the astronaut corps. Soyuz T-10a. On September 26, 1983, the crew of Soyuz T-10a, cosmonauts Vladimir Titov and Gennady Strekalov, were seconds away from launch to the Salyut 7 space station when disaster struck. A fuel leak at the base of the rocket ignited, engulfing the launch pad in flames. The onboard computer system failed to trigger an escape sequence, but ground controllers manually activated the launch escape system with just 2 seconds to spare before the rocket exploded. The escape tower's solid rockets pulled the Soyuz capsule away from the fireball, subjecting the crew to forces of up to 14 G before parachuting them to safety. While the astronauts survived, the incident was one of the most dangerous near misses in human spaceflight, leading to upgrades in automatic abort systems and stricter pre-launch safety checks. Space Shuttle Challenger. On January 28, 1986, the Space Shuttle Challenger broke apart 73 seconds after liftoff from Kennedy Space Center, killing all 7 crew members, including teacher Krista McAuliffe, who was set to be the first civilian in space. The disaster was caused by the failure of an O-ring seal on the right solid rocket booster. The O-rings were meant to prevent hot combustion gases from escaping, but unusually cold weather, temperatures were near freezing that morning, made the rubber seals brittle. Upon ignition, hot gases leaked past the compromised O-ring, igniting the external fuel tank and causing the shuttle to disintegrate. The crew cabin remained intact during the breakup and continued to ascend before falling into the Atlantic Ocean. The tragedy led to a 32-month suspension of the shuttle program, design changes to the boosters, and a reevaluation of NASA's decision-making processes regarding launch safety. Space Shuttle Columbia. On February 1, 2003, the Space Shuttle Columbia disintegrated during re-entry, killing all 7 astronauts on board. The disaster began during launch on January 16, when a piece of insulating foam broke off from the external fuel tank and struck the shuttle's left wing. The foam impact punctured the reinforced carbon-carbon panels that protected the wing's leading edge from extreme heat. During re-entry, superheated plasma entered the wing through this breach, melting the aluminum structure inside. This structural failure caused the shuttle to lose control and break apart over Texas at an altitude of about 200,000 feet. Debris was scattered over hundreds of miles. The tragedy halted shuttle flights for more than 2 years and resulted in extensive safety overhauls, including improved inspection and repair procedures for thermal protection systems before re-entry. Shenzhou 10C training accident. While not a space launch, this incident occurred during a ground-based training exercise for China's Shenzhou program. On October 14, 2003, just days before the first Chinese crewed launch, a high-altitude test in a training capsule went wrong, killing astronaut Wang Yongji's backup crew member, Chen Dong. The exercise simulated high-altitude depressurization, but a malfunction in the life support system caused oxygen levels to drop sharply. The crew was wearing partial pressure suits, which failed to supply adequate oxygen during the rapid pressure loss. The fatal accident was kept from the public for many years, and China quickly revised its training protocols, ensuring full pressure suits and redundant oxygen systems would be mandatory for all simulated or real launch environments. Virgin Galactic Enterprise. On October 31, 2014, Virgin Galactic's Spaceship 2 VSS Enterprise was conducting a powered test flight over California's Mojave Desert. The vehicle was carried aloft by its mothership and released at about 50,000 feet before igniting its rocket motor. Just seconds into powered flight, the feathering system, designed to slow the craft during re-entry, deployed prematurely at supersonic speed. This caused the spacecraft to break apart in mid-air. Co-pilot Michael Alsbury was killed, while pilot Peter Siebold was thrown from the wreckage and survived with serious injuries after parachuting to the ground. Investigations determined that the co-pilot had unlocked the feathering system too early, but also faulted the vehicle's design for lacking safeguards to prevent such an action during high-speed ascent. The accident delayed Virgin Galactic's commercial spaceflight program for several years and prompted extensive design changes to improve crew safety. Soyuz MS-10. On October 11, 2018, Soyuz MS-10 was launching to the International Space Station with Russian cosmonaut Alexei Ovchinin and NASA astronaut Nick Hague aboard. 2 minutes into flight, a separation sensor on one of the first-stage boosters failed, causing it to strike the central core stage during staging. This triggered an emergency abort sequence. The launch escape tower had already been jettisoned, so the spacecraft performed a ballistic descent, subjecting the crew to forces of about 6.7 G before parachuting safely to Earth. Both men survived without injury, but the mission was a total loss. The incident was traced to a faulty sensor installation during rocket assembly, and Russian space authorities implemented stricter quality control checks for all future Soyuz launches.